Hey, we're back for Unit 2 video lesson number 10 on the quantum model. So following Heisenberg, in 1926, Erwin Schrödinger derived an equation that predicts the probable location of an electron by treating the electron as a wave. This equation is called the quantum model, the wave mechanical model, or the modern model of the atom. But it's a pretty lengthy equation and kind of difficult to use, but keep in mind that it is an equation that the electron location is predicted from. What he said is that orbits do not apply to the wave-like behavior of electrons because they are described as fixed, definite paths. So the wave function, the equation, predicts the three-dimensional region around the nucleus where the probable location of the electron can be predicted. And this three-dimensional region is called the orbitals. The quantum model is defined by four quantum numbers. The first one, which is very similar to Bohr's quantum number, is called the principal quantum number, given a symbol of N, and this indicates the energy level within the electron cloud. So now we're really defining the electron cloud and where the probable location of the electron is. N equals 1 indicates the first energy level, which is the lowest energy level closest to the nucleus, up to N equals 7, the seventh energy level, which is the highest and the furthest from the nucleus. The angular momentum quantum number, given the symbol of L, indicates the shape of the orbital or the sublevel. And there are four sublevels: the S, the P, the D, and the F. And they go in order of energy. So S has the lowest energy, F has the highest energy. The number of sublevels that you have in an energy level is equal to the principal quantum number. So if N is equal to 2, then there are two sublevels in the second energy level. And so let's take a look at this. So we have N equals 1. That means that we have one sublevel, and that sublevel is the S sublevel. N equals 2, we have two sublevels, and in order of energy, we have the S and the P. In the third energy level, we have 3, the S, the P, and now we have the D. And in the fourth energy level, there are 4, the S, the P, the D, and the F. In the fifth energy level, we would, in theory, have 5. In actuality, there are only 4, the S, the P, the D, and the F. And that's the same for the fifth, the sixth, and the seventh energy levels. Now we can predict that if we had enough elements with enough electrons, then in the fifth energy level we would have 5, and we would go out to, let's say, sublevel G, which doesn't exist. So in the sixth energy level, we only have 4. In the seventh energy level, in actuality, there are only 4. The third quantum number is called the magnetic quantum number, and that's given the letter M. This indicates the orientation or the position of an orbital around the nucleus, or the number of orbitals that you have within a sublevel. Then we're going to take a look at each one of the sublevels and how many orbitals that we have. So in the S sublevel, the S is spherical in shape. It has 1 orbital. And we're going to see in the spin quantum number that you can only have 2 electrons per orbital at any one time. So we can have 2 electrons, okay, in that particular orbital that are moving around in a wave-like motion, constantly moving. And then we have our P sublevel. And in the P sublevel, we have 3 orbitals. And they go along the axis. So we have the P sub x, the p sub y, and then we have the p sub z. And again, in each one of these, you can have a maximum of 2 electrons. So we can have 2 electrons in this orbital. We can have 2 electrons in this orbital. And we can have 2 electrons in this orbital. And if we superimpose the 3 orbitals of the p sublevel on top of one another, it would take on this kind of shape. And keep in mind, to the interior of this, you have an s sublevel, and then to the interior of that, you have the nucleus. So our electron cloud is starting to take on this 3-dimensional shape. Now the d sublevel gets really complicated because now we have 5 orbitals in the d sublevel. And these are the 5, okay? And for each one of these orbitals, you can have 2 electrons. So we can put one here, we can put one here, and so forth. So the d sublevel, it's called d because this orbital here kind of has like a donut shape. P sublevel is called p because it has a peanut shape, or we can also say a dumbbell shape to it. And then lastly, we have the f sublevel. And in the f sublevel, we have 7 orbitals. We have 1, 2, 3, 4, 5, 6, and 7. And we call it F because it kind of takes on this flower looking shape that you have here. But in each one of these individual, they're complicated orbitals. But in these orbitals, you can have 2 electrons at any one time. Okay, so the last quantum number is called the spin quantum number, and this indicates the 2 possible spins of an electron. It has 2 possible values, a positive 1/2 or a negative 1/2. And what this number tells us is that any single orbital can only occupy 2 electrons in opposite spins. Now, when you have electrons, and think about this, electrons are negatively charged, and so if you have 2 electrons in close proximity of one another, they're going to have a tendency to want to repel because 2 are negative charges. However, when they're in opposite spins, it creates a magnetic attraction between those 2 electrons, so that helps keep them within their orbital. So let's kind of take a look at this. In our energy level, first energy level, we have 2 sublevels, or I'm sorry, the first energy level, we only have 1 energy level, which is the S. It has 1 orbital, and that 1 orbital can have 2 electrons. In the second energy level, we have 2 sublevels, the S and the P. In the S, we have 1 orbital with 2 electrons. In the p sublevel, we have 3 orbitals with 6 electrons. And so in the second energy level, that gives us a total of 8 electrons. Now, in the third energy level, we have 3 sublevels, the S, the P, and the D. The S has 1 orbital with 2 electrons. The P has 3 orbitals with 6 electrons. And now the D has 5 orbitals with 10 electrons. That gives us a total of 18 electrons in the third energy level. In the fourth energy level, we have 4 orbitals, the S, the P, the D, and now we're adding on the F. So we have 1, 3, 5, and 7 orbitals. The S has 2, the P has 6, 10 in the D, and now we have 14 in the F, and that gives us a total of 32 electrons. Now, if we take a look at the total number of orbitals, the second energy level has 4 orbitals. The third energy level has 9 orbitals. And the fourth energy level has 16 orbitals. So I want you to take a look at, and then you can pause the video here for a second, And take a look at the numbers that we have written here and come up with a mathematical relationship between the energy level, the number of orbitals, and the number of electrons. And then come back and we'll finish this off. Okay, so now that you've come back, our energy levels are represented by this symbol N. Okay, so if we take a look at our number of energy levels, or our number of orbitals that we have in an energy level, and look at a mathematical relationship, we can say that N squared is equal to the number of orbitals, and then our electrons would be equal to 2N squared. Because you can have 2 electrons per orbital at any one time. So let's say, for instance, we had 8 energy levels. Well, how many orbitals would you have in 8 energy levels? Well, you would have N squared. 8 squared is 64. And then if you double that, the number of electrons, then you would have 128 electrons in the 8th energy level if we had that many electrons and atoms that had that many electrons. Okay, so that is the quantum model. This is the modern model that we actually use today. Is the electron cloud is 3-dimensional, and it's quite a bit different probably than what you have learned about in the past. So this is the end of video lesson number 10. So long for now.